Now we'll work an example where we construct a confidence interval estimate for a population mean, sigma known. A simple random sample of 50 adults is obtained, and each person's red blood cell count in cells per microliter is measured. The sample mean is 4.63 cells per microliter. The population standard deviation for red blood cell counts is 0.54 cells per microliter. So our first question is to find the best point estimate of the mean red blood cell count of adults. Well, the best single value that estimates the mean is the sample mean, right? So we would say X bar equals, and would they tell us the sample mean 4.63. If we have one value to represent the population mean, this is it. That's our best point estimate. Okay, part B says to construct a 99% confidence interval estimate of the mean red blood cell counts of adults. Okay, well first we need to check our requirements. Number one is that we have a simple random sample. Well, they told us we did, so that checks. Sigma is known. Population standard deviation is 0.54, so it's known. Here's our simple random sample. So those 2 points check. The sample size must be greater than 30. Okay? N is 50, so that checks. Or we could have a normal distribution, but we don't know anything about the distribution of the population. It doesn't say anything about that. But as long as our N is 50, we're fine, because it said either or both of those conditions had to be met. So we get the N greater than 30 condition. Okay, so let's write some of this down. N equals 50. X bar equals 4.63. Sigma equals 0.54. And our confidence level, what our calculator calls the C level, is 99% or 0.99. That's where, right here is where we get that. Okay, so we'll use our TI 8384 technology. And we said we'd go to, let's see, turn it on, and go to Stat, Tests, and the Z interval. Tab down to Z interval. Okay, I do not have the raw data. All I have are stats. So I'm going to tab over to Stats to highlight stats. And then Enter so that it highlights stats. Tab down to Sigma. Sigma was 0.54. Tab down to X bar, 4.63. Tab down to N, 50. C level, and I've covered it up, but we can see it right here. It's 0.99. Highlight Calculate, hit Enter. Here's our interval. Okay, so now I can record the interval, and it's 4.4333, 4.8267. Using our round-off rule, we said the same as the sample mean if we don't have the original data, and we don't. And now we interpret our results. Okay, a nice sentence. We are 99% confident that the true population mean red blood cell count of adults is between 4.43 cells per microliter and 4.83 cells per microliter. Okay, finally, we might be asked a question such as shown here. Do the results support a medical researcher's claim that the population red blood cell count for adults is 4.7 cells per microliter? 4.7. Well, let's look at our interval. What we're saying here is we're just 99% confident that the true mean is in here. So 4.7 would be in our interval and could very well be the population mean. Since we're just saying it's somewhere in here and the researcher's saying they believe it is 4.7, then our research would support this researcher. So we could say yes, because 4.7 is in the confidence interval. Therefore, that could very well be the population mean.